Good morning. Today what we're going to do is start into Chapter 5, Pre-Calc 30. We're going to take a look at graphing sine and cosine functions. We've spent a lot of time solving trig equations that involved sine and cosine. But today what we're going to do is focus on the graphs of these functions. And we do that a lot in Pre-Calc 30. We want to see what the graphs look like, their characteristics, as well as work at solving the equation. So with Pre-Calc 30 and this trig stuff, we kind of go backwards. Last chapter, we focused a lot on the equations. Now we're going to take a look at the graphs. So how we're going to go about doing that is like this. I have a couple of tables set up, and you may notice some of the angles that I have here in degrees. Those are significant angles. We looked at these ones using the unit circle, 0 degrees, 30 degrees, 45, and so on. And what we're going to do is we're going to put them into a calculator to figure out what the ratio is. We're going to start with the sine, and then we will work to cosine over here. We're going to build a table of values, and then we're going to build ourselves a grid. So just to give you a sense of what we're going to do, my graphing calculator, we are going to evaluate what in degrees. I need to make sure my calculator is in degree mode. It is in degree, it says here. So if I do sine of 0, that gives me an answer of 0. So on my table of values, I will go back here and I will put in that I got 0 when I did sine of 0 degrees. I've got one done for you here. If you do sine of 30 degrees, it's 0.5. We'll do 45. Go back to my calculator. If I were to do sine of 45 degrees, it gives me an answer of 0.707. One decimal place is going to be more than enough. So what I'm going to do is just put down 0.7. And you will continue going through and complete the table of values. And you can see even the degrees, I have only got up to 135 degrees, but follow the unit circle angles, and you should be able to build a table of values. Once you have that table of values built, what you will do is go to a graph or a grid. I've started here. You will notice when you do your table of values that your sine ratios do not go higher than +1. They do not go lower than -1. And I started putting on a few of these. So here is 0 degrees. And when I did sine of 0 on my calculator, it gave me 0. Here's 30 degrees. I made my grid go by 30-degree intervals or increases. Sine of 30 was 0.5. 45, which would be in the middle here, was 0.7. And if you continue to plot your points for both your sine curve and your cosine curve, you will gradually start to build what will the sine and cosine graph is going to look like. Now, you may notice that I ended up doing my x-axis to 720 degrees, and that's perfectly fine. That's more than what my table of values gives you. But what you're going to notice is that as you start to plot these points until you get to 360 degrees, you're going to end up with a curve that looks something like this. If you were to continue going to 720, you're going to end up seeing a curve that is able to repeat itself. It's going to look exactly the same. And based on what we did in Chapter 4, you know that we could have angles larger than 720 degrees, or we could go into the negatives and you would have angle measurements, ratios, for negatives. And what you end up building is a curve that looks something like this. And we're going to talk a little bit about the characteristics of this curve. For a sine ratio, I guess I should highlight that. This first one is the curve for a sine equation. And this one here is for cosine. And you will notice that they are very similar in shape. One of the biggest significant differences between the two graphs, and I'm going to try and peek and see a little bit of both, is that at 0 degrees, the cosine curve has a value of 1, whereas the sine curve up here had a value of 0. And so they start in different places, but they follow a very, very similar pattern. So when I had the table of values built and my grids here, I used degrees. It would probably be wise to also mark in some of those significant radian measures. If you were to go on your calculator and change it to radian mode, and you did sine of pi over 2 instead of 90 degrees, you would end up with the same exact curve, just using a different measurement. So I've marked off some of my significant angles in radians. 90 degrees is pi over 2, 180 is pi, and so on. You can see I went forward with those radian measurements. And I also marked off again, remember that 30 degrees is equivalent to pi over 6, or 1/6 pi. 45 degrees here is 1/4 pi. And it's nice to have these graphs drawn by hand. It gives us a better appreciation for what the graph looks like. And we can have this curve in front of us as we go forward, answering some questions about these graphs. So what we will be doing with a sine and the cosine curve is we're going to be talking about their characteristics. And so something like this. For a sine curve, y equals sine of theta, on this interval, now this is called interval notation. This is saying for all the angles that belong to this interval, the square brackets imply that 0 radians is included, up to 2 pi is included. And now we would have seen it more in inequality notation if we're talking about all the angles theta that are greater than or equal to 0, but at the same time less than 2 pi. So this interval notation means the same thing as what we have here. Just another way of writing it. So what they're asking us to do is to look at a sine curve, which I have graphed here below, between 0 and 2 pi. And they're asking us about some of these characteristics, like the maximum value. When you look at the maximum value, we're looking at the y value. The highest that our graph went was up to 1. Maximum value is 1. Minimum value, how low did our graph go? The lowest that our graph went, it bottomed out at -1. And nowhere, even when the graph starts to repeat itself, does it ever go above that +1 or below the -1. The interval over which the pattern of the function repeats. How many radians or how many degrees along the x-axis did we go until we started to see the graph repeat itself? And so when you look at the graph here, it's on its way up from the x-axis. And right here where we started, it was on its way up from the x-axis. So how many radians did it take? The interval before repeating was 2 pi. And again, remember, in degrees, that would be the same thing as 360 degrees. The zeros of the function. The zeros, remember, are the x-intercepts. And in this particular graph, we have an x-intercept at 0, at pi, and 2 pi. So we have, and I'm going to write it as an ordered pair, 0 radians across, 0 up, at pi radians across, and 0 up, and at 2 pi radians and 0 up. Those are where our x-intercepts are. It's asking about the y-intercept, and again, our y-intercept is here at 0, 0 as well. 0 radians across, 0 up, and then the domain and the range. Now, domain, by the graph, the arrows going in this direction and this direction, we would be able to solve our, or evaluate our equation for any x value. And I'm still going to use x's, even though the graph is using theta. That would be the same thing as me saying theta, because that's the unit for the x-axis. Can be any real number. And then our range. Our range, again, the lowest end it went was -1. Our y values are up to including positive 1, and we can talk about real numbers in between. So that's basically some of the main characteristics that we have for our trig graph, a sine curve. We'll talk about a cosine curve in a second. But one of the things that I wanted to show you with this graph, and I'm going to be a little bit repetitive going forward, is that our graph is built really in 4 sections. And it's easy to see by some of the significant points that we see on our graph. Essentially, between where our graph started to where it reached its maximum, where we had another x-intercept, where it reached its minimum, and then back to where it started again. There are actually 4 sections. You'll see 1 section here, 2 sections, 3 sections, and 4 sections to our graph. And I'm going to harp on them, I guess, a bit, because those 4 sections are really important as we go forward when we need to be able to graph our own trig functions. So that was a sine curve. Here is a cosine curve, and they want us to do the same kind of summary that we just did with the previous question. And so what I'm going to do is we'll talk about, again, the maximum value. And if you look at this graph again, it doesn't go any higher than positive 1. The minimum value. The bottom of the graph is at negative 1. We talked about the interval over which it repeats. And again, you will notice that our graph, when we started it at 0, was up here at 1. And by the time it got back to being in that exact same position, back at the top over here, was 2 pi radians later. And again, it's in the same position. Our graph was on its way up to the maximum and coming down, on our way up and to the maximum and coming down. So that's kind of how we know that's starting to repeat itself. But again, it was 2 pi radians that it took for it to finish one complete section of its curve. It wants to know about the zeros of the function, or those x-intercepts. And this graph is in a little bit different position, so its x-intercepts are in different places at pi over 2 and 3/2 pi. So again, I'll write those as an ordered pair, pi over 2 and 0, and 3/2 pi and 0. It wanted to know about the y-intercept, and this time the y-intercept is up here at 0 across and 1 up. It wanted to know about the domain and the range. And the domain, when you take a look at it again, the angles can go into the negative, they can go into the positive. There's nothing stopping our graph from extending all the way across the x-axis, so x or theta if you want, and our range is going to be very much the same. It was lowest at -1, and our y values climbed all the way to +1, and it can be a real number. So when you take a look at this cosine curve, again, when you take a look at it, even though it's a slightly different positioning than our sine curve, from where we start and we hit some of these significant points like the x-intercept, the lowest point, back to an x-intercept, and then where we see our highest point, we should see those 4 sections, section 1, 2, 3, and 4. And so those again are going to be a bit of a significant point for us going forward. Okay, so when you take a look at these curves, sine curve and cosine curve, we should be comfortable with some of the significant sections of it. We're going to go forward and take a look at how we are going to graph them and make sure that we can understand some of the main characteristics to these curves. So that's where I'm going to stop for today. We'll pick up a little bit more in section 5.1. Have a good day.